Hello, in this video we're going to graph the function y equals x squared plus 2x minus 3 and use that graph to solve the equation x squared plus 2x minus 3 equals 0. So let's begin with the function y equals x squared plus 2x minus 3, and there's not going to be anything new here. A is 1, b is 2, and c is negative 3. And therefore xv, the x coordinate of the vertex, minus b over 2a is going to be minus 2 over 2 times 1. That'll be negative 2 over 2, which is equal to negative 1. So we make our table now. And remember, we have different rows and columns, so it's going to be x and then x squared, and let's leave a little bit of room for the x squared, and then plus 2x, leave a little bit of room for the plus 2x, and minus 3, less room for the minus 3, and then y at the end. Okay, so here is our the outline of our table, and we're going to put negative 1. Okay, this one is going to go into the fourth row of the table. Okay, it's the x in the fourth row, so let's create some rows here. 1, 2, 3, 4, 5, 4, 5, 6, and 7. Okay, so the fourth row down, 1, 2, 3, 4, negative 1. Okay, so then use whole numbers on either side of that. 0, 1, 2, and going backwards, negative 2, negative 3, negative 4. Okay, so the first column is x squared. That's just going to be negative 4 squared, which remember is going to be positive 16. If you square a negative number, you get a positive. Then I have negative 3 squared, so that's positive 9. Negative 2 squared, which is going to be positive 4. We don't need that parentheses there. Positive 4, negative 1 squared, which is positive 1, 0 squared, which is just 0, 1 squared, which will make positive 1 just because we've been using positives the whole way down, and 2 squared, which is positive 4. And we have plus 2 times x, so plus 2 times negative 4, that's negative 8, plus 2 times negative 3 is negative 6, plus 2 times negative 2 is negative 4. And very often you can see a pattern within these rows. This should be plus 2 times negative 1, which is negative 2, plus 2 times 0, which is 0, plus 2 times 1, which is positive 2, and plus 2 times 2, which is positive 4. Now the third column, the minus 3, is just minus 3 the whole way down. Okay, so we're just going to go minus 3 the whole way down. Alright, let's add up the results of each column. So in the first of each row. So in the first one it's going to be 16 minus 8 is 8, minus 3 is 5. 9 take away 6 is 3, minus 3 is 0. 4 take away 4 is 0, minus 3 is negative 3. 1 take away 2, take away 3. Minus 2 minus 3 is minus 5. Minus 5 plus 1 is minus 4. 0 and 0, negative 3. 1 and 2 is 3, minus 3 is 0. 4 and 4 is 8, minus 3 is 5. And if you look from the center out, you see that symmetry in the numbers, negative 4, negative 3, 0, 5. So the points here are going to be negative 4, 5, negative 3, 0, negative 2, negative 3, negative 1, negative 4, 0, negative 3, 1, 0, and 2, 5. Okay, so those are our points. And the next thing that we need to do is we need to graph this. This is, again, something we've done before. So what we're going to do here, we'll just, at this point here, we'll just paste in the graph, okay? And it's a little bit big, so, but it's okay. That's fine, actually. So if we do scale 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay. Right, so we can start plotting points here. So the first point is negative 4, 5. So over to negative 4 and up to 5. Okay. Negative 3, 0. Over to negative 3 and up to 0. Okay, that's another one. Negative 2, negative 3. Over to negative 2 and down to negative 3. We have a point there. Negative 1, negative 4. Over to negative 1 and down to negative 4 is here. 0, negative 3 is the next point. 1, 0 is over to 1 and up 0 is there. Then 2, 5. Over to 2 and up to 5. Okay, and we can see, I think here, we've got that symmetry. Okay, so let's just draw the graph. Goes horizontal for a moment through the vertex, and then it curves up, and it goes through all these points. And remember, you're not using a ruler. There's not meant to be any straight lines here. So you do the best freehand job you can. And if it's not perfect, don't worry, because your teacher's is very, very far from perfect as well. Okay, so there we are. Now, what we had to do was the solution of the equation. Okay, so this is the graph. This is the graph of the function y equals x squared plus 2x minus 3. Okay, so that's the graph of the function. Now, what we're going to do is we're going to use it to solve the equation and you generate the equation by replacing the y with 0. Okay, so instead of y equals to x squared plus 2x minus 3, we're going to make it x squared plus 2x minus 3 equals 0. And what we do is we find the points where the graph crosses the x-axis. Okay, find or just highlight the points where the graph crosses the x-axis. And in this case, it's very clear that it's going to be here and here. In other words, x is equal to 1 and x is equal to minus 3. Okay, x is equal to 1 and x is equal to minus 3. Alright, and that's all there is to it. Okay, just these points here. Okay, where the graph crosses the x-axis. That's all you have to do. That's all you're looking for, even if it keeps disappearing on me. Okay. Of course, you would get the same result by factoring, so let's do that. You're not going to be required to do this, but I'll show you that you get the same result by factoring. Okay, so again, remember it was x squared plus 2x minus 3 equals 0. Well, now that's a trinomial, a simple trinomial, because it begins with 1x squared. The factors of x squared are x and x. Then we want factors of 3 that subtract to give 2. So the only factors of 3 are going to be 1 times 3. Okay, they're the only factors of 3. So let's put the bigger number first. 3 there, 1 there, and this is going to be equal to 0. Okay, first sign goes in front of the bigger number, so put a plus in front of the 3, and the signs are going to be different, so a minus in front of the 1. And put both of them equal to 0, x plus 3 equals 0, x minus 1 equals 0, and if you get x on its own, this gives you x equals 3, and x is equal to 1. X equals minus 3 here, obviously. Sorry, I forgot about that. X equals minus 3. You take the 3 across, it changes sign, becomes x equals minus 3. And here, bring the negative 1 across, becomes change sign, becomes x equals 1. So we have the same answers that we had up above. And obviously there'd be a problem if there weren't the same answers. But hopefully you can see how to do it by graphing. If you have the graph, then the solution is simply the points where the graph crosses the x-axis. Okay, thanks for watching this far.